We have your stars, well. So basically, we have 4 inverters here. So like I said before, each inverter is 6 kV, 6 kV, 6 kV, 6 kV, 6 kV. So we combine the inverter in parallel in order to achieve 24 kV. Bar. So the reason why we did that was the load in the house is about, let's just say, 15 kV. You understand, bar? So we are not able to get single 15 kV. So just brought the idea of getting 6 kV and then combine it together. So I know that once you have load of let's just say you have load of 10 kV, you must not use inverter of 10 kV, otherwise you kill the inverter. You need like 15 kV or 20 kV so that the inverter will last longer. You get? So that's why we install 4 of these inverters. So like I said, the inverter connected in parallel. The parallel means that they are joining their power together in order to achieve the 24 kV that we need. So starting from how the connection started from, the 2 battery here is parallel too. So the inverter is rated 48 volts and the battery too is rated 48 volts. You understand? So it's just as if you connect plus to plus. But since there are a lot of them, we bring the positive of this one, the positive of this one to this bus bar. This is called bus bar. So if you open it here, there's this part here, there's a bar here, which all the positive, meaning the positive of this one, the positive of this one, the positive of this one, all of them with the positive of this battery too come in here. There's a bus bar here, so all of them is connected here. Then the same thing with the negative. All the negative is here. Then all the negative of the inverter come here too. So we have powered the inverter up. You understand? Then going to the parallel, the inverter outputs. If you look here now, you see load. If you look here, load. If you look here, load. So all the load, there's life and neutral. So all the neutral of this one, neutral of this one, neutral of this one, of the load, all of them combined together. Understand? That's 4 bar. Okay. This one, all of them combined together as one. The same thing. You repeat the same process with the inputs, life and neutral, the outputs, life and neutral. That is the parallel. You understand? All of them are joining hands together. You understand? Then before you do that, you see there are communication cables here. So all of them are communicating. That one you from the manual, you get how to do that one there. So you see all of them. So they are acting as one. If you look here now, there is load of 60 watts here, 60 to 50 watts here. If you check this one too, it's the same thing. Basically almost the same thing. See, this one shows 50 something, this one is like 20 something. If you check it, basically they'll just share the load among themselves. This one now is 655, this one too is 55. Then let's see this one. That I don't even bring myself. So this one too is like 30 something. So basically they'll just share the load equal. You understand? Okay. So the more you power, if you put load of 1 kilowatt, let's say the on load of 1000 watts, now you to divide it, that's 250. So they'll be communicating with themselves like that. So that's how it is. You understand now? All the outputs, life and life all together. The inputs, life and life all together. That's how they do parallel. The same thing we do here. All the negatives together, all the positives together. That's how they do parallel. Then if you look here, so I say that we are going to be using, out of these 4 inverters now, we just send solar panel to 3 of them, which is 1, 2, and 3. You understand? So once the solar panel come here, they're still charging the same battery. In future, if they want to add panel, they can decide to add panel in this particular one. But all of them, the power of the solar panel is still coming to the same battery. You understand? So that's why we have 3 surge protectors here. This is DC surge protector 1, 2, and 3. Then you have DC breaker 1, 2, and 3. So this one's now will be controlling the solar parts. Once you off this one, the particular inverter that this one is connected to will not have solar power. So that's this one. So this is breaker, DC breaker, and this is DC surge protector. You know the work of surge protector now? Help from thunder, so that in case thunder want to strike, it will help to prevent thunder from affecting the system. So So that's what is here. Then come to this side now. We have surge protector. So this surge protector is AC. It's the same work they are doing. They are still protecting against thunder. But the reason why we put this one here is in case, let's say the thunder follow national grid and come in. So instead of the thunder to affect the inverter from NEPA part, this one will hold it. And this one will protect it from solar panel. From the panel part, you understand? Then we have voltage protector here. The use of this voltage protector is once in solar system, it doesn't like full light or it doesn't like low light. If you look here, so everything that you need is here. If you look here now, the said input is 230 volts. So any light that passes 230 volts will affect this thing. So that's why we put this voltage protector here. So we'll program it that the light should not be more than 230 volts. Any light that is more than 230 volts, this voltage protector will block it so that it will not affect any of these things. So there are two here. We just combine them in parallel. You understand? That 100 amps. So we just combine them in parallel so that it will be strong. So both of them are doing the same work. Then we have our input breaker. So this breaker now, once you on it, you saw there is lights here. So NEPA light now is entering this system. You understand? Once you off it now, see now, if you look all of them, I'll show you sign that NEPA have entered. So once you off it now, you are shutting down grid. That's NEPA from the system. So as of now, the battery is fully charged. So what to discharge it, that's why we leave it off for now. So then this one to change over. The way we program the changeover, up will be for solar, down will be for bypass, or if you want to use direct NEPA lights. So basically, everything you need is in the manual. I just go through the manual. Then for now, we're going to be sending our solar panel, like I said. We'll do them 8 series. We have 24 bar. Yes, we'll do them 8 series. So 8 series now. Each 8 panels will be coming to each inverter. As we bring one here. So from there now, solar panel will start charging the system. Then also we connect the battery in parallel and we communicate it. So if I off one battery now, okay, let's try it. If I off one battery now, the whole battery will shut down. See that everything have shut down because they are communicating together. See that everything have shut down once. So no need to be offing this one, offing this one. Once you communicate them, they'll be working together. The way that if you pull load on this one, both of them will share the load, the same thing. You understand, bro? So once you on this battery now, both of them are on. Yes. So you see everything will start coming on back. So basically, that's how everything is. Now understand? Yeah. So when I know the way I'll do the wiring shop, but nothing will happen. You see, I'll just draw simple diagram. But basically, what I explain is everything that is here. You understand?
So sorry, so basically, after the connection from the panel,
yeah.
So three inverters will be active.
After the connection of the panel, 3 inverter will be charging the battery.
Okay.
You understand? Yeah. See, even you use only this one, you connect panel to only this inverter, it will still be charging the 2 batteries. Because all of them are connected parallel. Yeah, you understand? So the charging system is from this side because the 2 batteries are already meshed together as one. Okay. So all of the power will come from here and still go to the same battery. You understand, bro? So even though you choose to put only one, yeah, it will still power the batteries here. So that's all. Paul.
Sir.
No, this Paul. Come. Basically, this thing here. So that's parallel. You understand? Then this side, if you look here, these 2 red, one is for this battery, one is for this battery. Then each inverter, this inverter pick his own, another inverter pick his own, another inverter pick his own, another inverter pick his own. You understand? So this, they call it bus bar. You use this one to connect all of them. You understand? Normally, you're supposed to carry all the 4 wires, join them together, 4, and just twist it together. But it's not professional. If you do it like that, that's nonsense. You understand? So you use both the nuts with, you understand, with the cable locks to tight it where. That's the parallel. So the same thing with the outputs. Now, in the outputs now, if you look here, all of them are here. If you look here now, there are 4 wires here. This black is 4. So all the outputs, 4 of them is here. If If you look here too, there are 4 here. So this is where the parallel happen. This is where we join all the wires together. You understand? Then the input is inside here. We did it. You understand? But that's where all the parallel happen. Like I said, all of them. If it's life of this one, life, all of them will join together. If it's input, all the inputs will be together. If it's output, all the outputs will be together. That's what happened here. You understand? That's the parallel. But you must note, before you do this kind of parallel, before you join all these things together, there are programs you're supposed to do on the inverter. Otherwise, if you do not program the inverter and you just do it like that, immediately you power it, everything will catch fire. There are programs. If you look at the manual, let's go to the settings. This one, I'll talk with that side. If you go to the setting, then you go to 20. Look here, parallel, PL. So the inverter, all of them, if you open the same thing, you see it's PL. So you have to set it on parallel. The follow com setting is not on parallel. The follow com setting is single. On default, this is follow com. The follow com is on single. So as you are combining them as parallel, you have to set it on parallel. See it, 20 PL. So all of them, you have to set all of them on that parallel. Once you have put all of them on parallel, there's a video I did about that yesterday. After you put all of them on parallel, you go to the menu, deep down in the menu, you see the wiring diagram. Single phase parallel connection. See the diagram now. Single phase parallel connection diagram bar for 3 to 12 inverters. Means that you can connect up to 12 of them in parallel to achieve one phase. That's why you say single phase. This is single phase. You understand? At the end of the day, we just get one life and one neutral after a combine of them. So you see the wiring diagram. See everything that we did here is here. See that all the batteries, see battery, all of them are combined to one. So these two batteries now they're acting as one. That's what happened here. You see it here, battery back. Then if you look here now, this port, this pin here, this connector, that is it here. You see what? Then this wire come to this place. If you look here, come from here to this place. Then from here to the next inverter, which is this one. That is from here to the next inverter, which is this one. So from there again, you continue repeating the process. So once you end it, you use this one to finish up. As we end it here, you see we use this one to end it here. So once you go to your settings, you do that, you change it to parallel, then you put these cables like this, you are good to go. Then there's another setting. Since you are using lithium battery, you set it to lithium too. Once you open your factory setting, you enter, you go battery LIB lithium. That's one bar. You go to the manual too. So everything you need is in the manual. That's why you have to study your manual. See, on default it is AGL. That's 1/01. So we set it on LIB. LIB is what?
Lithium battery.
You see, because we are using lithium battery. Then after we set all of them, if you look all of them and they're on the same setting, then there's what they call communication cable from the battery. So you see this cable now. We link this cable to one of the inverter. You get to one of the inverter. If you look at the right BMS there, everything too is on the manual. Anything, all these things that we are doing here is on the manual. So once you have put that cable and have set it on lithium, the inverter is recognizing that the battery is on lithium. So look there, check how many percent that battery is showing. See it, 99%. So that it's communicating due to this cable that we connect. This communication cable. If you don't put this cable, you can't see that percentage. So now the inverter is communicating with the battery. Anything that is going on here, the inverter is aware. Anything that is going on here, the battery too is aware. So let's go back to the main screen. For those of you that are just joining us now, you see here the right AC 0, output 230. So currently now the inverter is on. This is the output. Then let's go off. Now it's showing AC frequency. This HZ. Those are going on a regular electrical school. HZ is frequency. That's has. Then now it's showing PV 0. If you connect solar panel now,